Hi, this is Mrs. Slater, and the quote for the day is going to be from Walt Disney. It's kind of fun to do the impossible. And then the joke for the day is, when does it rain money? And what did one eye say to the other eye? All right, so the lesson today is all about geometric series, but this time it's going to be infinite series. And there's a couple things that I want to tell you before we begin. So on your notes, you can write it somewhere on the right side of your paper, and then we'll go ahead and get started. Let me get a new page. So for the first part, if you're talking about a series, I want to talk about the definition of a series. Okay. It is the sum of the terms in the sequence. Okay, so there are two types of series. You've got the finite, which we already talked about in the previous section, series, and then you have the infinite, which is the main focus of today's lesson. Okay, in a finite series, this is the sum of the first n terms. Okay, and then for an infinite, it's going to be the sum of all terms as n approaches, which is what the arrow is signifying, infinity. Okay, now you may think how that is possible. We can actually find the sum of numbers that go on forever. Sorry about that. And I'll show you some examples tomorrow that makes more sense. Okay, so anyway, back to the finite. Yes, previous lesson, we had the sum, and then we would add a whole bunch of numbers together, and then all the way to the last term that we wanted to. So 7 terms, that would end with a sub 7. So I'll just leave it with n. And then today, what we're going to see is the sum of infinite terms. So you would take a1, a2, and continue that on all the way to infinity. So it just keeps on going and going and going. So those dots are representing that. Okay, the formula we use for a finite is the sum of n terms would be a1 times 1 minus r to the n over 1 minus r. The formula we're going to be using today is much simpler. So we have sum of infinite terms, the first term times 1 over 1 minus r. Okay, now there is a restriction. You must have the absolute value of r less than 1. Otherwise, you cannot find the infinite series. So there are some special circumstances there. Okay, which leads us to the first examples. Let's determine if these are infinite geometric series. Okay, so let's do the test. And I believe I may have skipped a step here. Yeah, there it is. Okay, so here we have the first one. The test is taking a2 over a1. A sub 1. So then 16 divided by 4 is 4. Okay, this does not meet the requirement of the absolute value being less than 1, so that's out. Cannot find the infinite sum there. Okay, the next one would be negative 30 over 5. This too does not pass because negative 6 is too big, so that one's out. We cannot find it. And the next one, we have 1/3 divided by 1, which is 1/3. And the absolute value of 1/3 is definitely less than 1. So we will be able to find the sum of this geometric series. And then the last one, you have 5 divided by 1, which is 5. And this, again, once we're right back to where we started, it does not work. Okay, now the one that did work, I have an example to use. And it looks like this. Find the sum of the infinite geometric series. So we already know that 1/3 divided by 1 gave us a common ratio of 1/3. So let's use that in this new formula that I just showed you, which is the sum of infinite terms. The first one is a1, and then you multiply by 1 over 1 minus r. Even simpler, we can have a1 over 1 minus r. That'll eliminate some of the work. So the a1 is 1, because that is the first term. 1 minus 1/3 will help us with the denominator. and 1 over 2/3. If we multiply by the reciprocal, we get 3/2. So our final answer for number 5 is 3/2. Okay, on the next one, if we're going to find the common ratio, it's -1 over 4. And that does pass the test because this number equals 1/4, which is less than 1. So we know that that's going to work. Common ratio is -1/4, so let's use that in our formula. The first term in this sequence is 4 over 1 minus a -1/4. Now, two negatives are going to make a positive, so we have 4 over 5/4. And if we multiply 4 times the reciprocal, we're going to get 16/5. So that would be the sum of that infinite geometric series. All right, I want you to go ahead and try, push pause and try the next one by yourself. All right, now that you're back, let's see how you did. 25 over 50 is going to help us find the ratio. And if we reduce that, we end up with 1/2. And that does, it is less than 1, so we are going to use it on our formula right here. So we have sum of infinite terms. The first term is 50, and you have 1 minus 1/2, which is 50 over 1/2, which then is 100. So the answer there is going to be 100. And then again, push pause, see if you can get the last one. And here we go. The ratio is going to be 1/8 over 1/2. And if you multiply that by the reciprocal, you get 2/8, which then is 1/4, which meets the requirements of finding geometric term. So we have sum of the infinite terms, and the first term is 1/2 over 1 minus a 4th. And after a little cleanup there, you should have gotten this already, which is 3/4. 1/2 divided by 3/4 is going to be, leave, change the sign, flip. So you get 4/6, which then is 2/3. So if you got 2/3, good job. So before we move on to the flubber question, I first want to talk about the infinite geometric sequence, because I told you we're going to do some examples tomorrow, but I also want to give this to you so you can answer the number 21 in your packet, or in your assignment for tomorrow. Anyway, so if this is somebody's hand outside of our door and they're dropping a tennis ball, and I know that's not a tennis ball, or some kind of ball that bounces, right? It's going to drop to the floor, and then once it hits, it's going to bounce back up again. Now, not necessarily will it bounce away from it, but I'm just going to show the bounce horizontally. And then once it hits the ground again, then it's going to bounce up, and then bounce up, and bounce up, and bounce up, and bounce up. Okay, so it continues doing that pattern. Now, as you know, in reality, it's going to end, it's going to stop, because it is going to hit the floor. So that's why we can say that there is a sum of an infinite geometric series. Now, what connects everything is the fact that this may be a common ratio of 1/2. So it has a bounce of 12 maybe, and then it bounces up 6. So this would be 12, and this would be 6, and so on. So just to get an example of this, let's just get a new problem. And I want you to write this down as well. Okay, so how far, and again, this is going to be like number 21 in your class assignment. How far up and down will a ball travel before stopping if it is dropped from a height of 60 meters, and each rebound or each bounce of, each rebound is 1/6 of previous distance. All right, so let me explain this to you. First of all, the person, we could call that from our window, they are 60 meters high, and then the bounce is going to be 1/6 of its previous drop. So think about, push pause and think about how that would happen. So you probably already figured out that 1/6 is going to be the common ratio, and let's try this in our formula. So the sum of infinite terms, the first term is going to be 60. Well, in this case, it's going to be 30 because this distance right here, we cannot count because we're trying to double. So like right here and right here and right here, we're trying to get all of those sides. So we're going to go ahead and use the 30, which makes this problem a little tricky. That's why I wanted to get an example of it. And then 1 minus 1/6. So we end up getting 30 over 5/6, which is 30 multiplied by the reciprocal. And that's going to be 180 over 5, which then equals 36. Now we're going to have to double that. So all the green that we put in the picture, that's 36. Since there is up and down, like the problem said, we have to multiply that number by 2, and you get 72. So now we've got everything from here to here. The one last thing we have to do is add the 60 to get 132 meters. Okay, we'll go over that more tomorrow, and then we'll talk about the flubber question tomorrow and do some examples in class of what this means. So the answers to your riddles are going to be what or when does it rain money when there's a change in the weather? So good job if you got that one. And then what did one eye say to the other eye? Between you and me, something smells. This concludes 14.4.